This is my presentation on don't wait for LabVIEW R&D, but implement your own LabVIEW features. In this presentation, I'm going to be covering every single hook into the LabVIEW editor that is available for adding your own G-based features into LabVIEW. This presentation is already available on ni.com, bit.ly/dnat/lvhooks. You can download the slides, and there's also a link to a video recording. Now, one of the things I usually do in my presentations is instead of putting links in them, I'll put Google search terms like, go type this into Google to find this page. Well, there are so many links in this presentation, I just included them as actual clickable links as opposed to Google search terms. So definitely download the slides to gain access to all of the links that are in the presentation. So today I'm going to be talking about VI scripting. If you want to add a feature to LabVIEW with LabVIEW code, you're going to have to know something about scripting. So I'm going to give an introduction to VI scripting. Then I'm going to talk about the features in LabVIEW that have hooks for you to write your own scripting code. Quick drop plugins, right-click plugins, pull-down menu plugins, and VI analyzer tests are the most common, easiest ways to hook into the editor. But there's a whole bunch of other miscellaneous ones as well that I'll be describing. And then at the end of the presentation, I'll be talking about rusty nails. If you haven't heard that term in relation to LabVIEW, just wait a little while and I will explain what that means. But first, I'm going to talk about scripting. If you're going to implement your own LabVIEW feature, you will probably at some point need to use scripting. Now, if I were giving this presentation in person, if we were in a meeting room at NI, I would ask how many of you have used scripting before and you know, look at the show of hands. But we're all in our respective home offices right now, probably. So instead, I'm going to assume that some of you attending this meeting have never used scripting before. So I'm going to give a basic introduction as to what it is. And it's really basic because it's a really easy answer. Scripting is just VI server. That's all it is, but just a few more things added to VI server. So if you think about VI server, you're almost always using it to modify properties of a VI or properties of the front panel of a VI. For example, this is VI server code that I'm showing on my screen right now. We have a VI reference. We look on the front panel of that VI to find a control called myBoolean, and then we change the visible property of that Boolean to false to hide it. That is an example of very simple VI server code to manipulate the front panel of a VI. You can use VI server to manipulate controls and indicators, VI properties, and things inside of the project window. Well, with scripting, you can do those exact same things, only it's providing more things that you can change, and it opens up the ability to make those same changes on the block, those same types of changes on the block diagram. So if we look at the bottom picture on the slide, we'll see that we have a VI reference. Once again, we are using a VI to search for a while loop on the block diagram. And when we find it, we are using an invoke node to call a method to add a shift register to the border of that while loop. So you can see the bottom picture is scripting code. The top picture is regular VI server code. They look like the same thing. It's just some new stuff that you can do with scripting. That's all it is. By the way, that blue sub-VI that's in those screenshots is an extremely useful VI, but it's not officially supported. It's not in the palette or anything, but I use it so much, it's going to come up at least like 3 more times in this presentation. So I figured I would just call it out specifically right now. It's a hidden gem. I gave a presentation to the TSC group on hidden gems last month. You can find the link to that. You can go to ni.com/hidden gems. All of that to say, this VI that is extremely useful for scripting is a hidden gem, and it's called tref find object by label. It's not the last time you're going to hear about that VI in this presentation. So, pretty simple. It's 2 checkboxes and tools options. That's all it is, and you can enable scripting. If you check the first box inside of that red box there, the first checkbox, what that's going to do is that's going to add a new palette in the application control palette that has about half a dozen items related to scripting. It also adds several classes to the VI server class hierarchy, which I'll talk about in a minute. And then the second checkbox there, what that does is that adds additional information to the context help window that is useful for scripting applications. So if you check that second checkbox there, your context help window is going to start looking like the picture in the bottom right, where we have all of those numbers next to the names of terminals in the context help window. And those numbers give you the index of that terminal on that sub-VI. So if you need that information for scripting, it's very easy to grab it there. Also, you see that number after the file name. That's the connector pane pattern of that particular VI, because that's also a piece of information that's useful when you're dealing with scripting. So when you are working with the object hierarchy in VI Server, let's say you drop down a control reference on the front panel, and then you right-click on it to change its class. You'll see a class hierarchy like what you see on the slide here. There's the parent class of GObject. Underneath that are things like panel and splitter and control. Under control, there's numeric and Boolean and string, etc. That's a class hierarchy that you've probably seen at some point if you've ever worked with VI Server. Well, in scripting, there's just a whole bunch more stuff that's added to that class hierarchy. So under the GObject class, you still have all the stuff on the left of the slide here, but you also have a whole bunch of new classes: diagram, wire, terminal, node, structure, all sorts of new classes available for you for manipulating with scripting. There are 3 learning paths that I'm aware of for scripting. The first one is the shipping examples. So if you're the type of person that just likes to browse the examples yourself, this is where you go. You go into this folder in your LabVIEW folder, and there are several subfolders under VI scripting, some pertaining to creating new objects, wiring, connector pane manipulation, all sorts of different categories for doing scripting operations. And within there, in a given subfolder, there will be an LV proj that you can open up, and it will make it very easy to navigate the top-level examples for that category. If you prefer a more structured, guided approach to learning scripting, then the scripting tutorial that's part of the LabVIEW help is a very good resource. In fact, what it does is it guides you through those shipping examples in a more structured way, as opposed to you just browsing them yourself. And then the third way to learn scripting is to just browse the features that are built on top of scripting. So you've got quick drop plugins, RightClick Plugins, and VI Analyzer Test. Those are all things I'll be talking about in this presentation. But you can go into those folders and start browsing and just looking to see how those features were implemented using scripting. The vast majority of that code is not password protected. So you can go in, you can browse through the code and kind of learn just sort of hands-on how those features were implemented. But enough talking. I'm talking about all these ways that you can create features in LabVIEW. Why don't I just go ahead and create a feature in LabVIEW right now before your very eyes? Before I create that feature, though, let's do a little bit of background. So here's an example of an application. Now, somebody else wrote this application, and they gave it to me, and they said, hey, we need you to add a feature to this application. We want you to delete the log file that's created by the application when it initializes, so that we know that we always have a clean log file. So I say, okay, I take a look at this code. I haven't seen it before. I go to the block diagram, and I see that it's a really simple state machine. All right, that's fine. Well, let me go to the initialize case, and this is where I'm going to add that code to delete the log file. So I'll put a delete function in, and I happen to know the path of the log file. All right, so now the feature's done. That was really simple. I added the code to go delete the log file if it's there. And if it's not there, I don't really care. So I'm going to go ahead and run the code. Well, right away, something terrible happens. If y'all have seen any of my previous presentations, you know that I'm not the biggest fan of automatic error handling. Well, it turns out whoever wrote this VI and gave it to me had automatic error handling turned on. But I didn't know that when I wrote the code. I didn't expect that to be on. That's not how I write my VIs. And yet here's this terrible feature that's enabled in this VI that automatic error handling is turned on. So right away, I'm like, well, oh crap, I have to worry about that now. Well, let me go ahead and continue. Now that I've made that change, let me go ahead and test to make sure the application works properly. So I click a button, and again, I find something else that's wrong. It looks like this dialog is empty. I didn't make a change to do that, but that's probably not what's supposed to happen. Okay, well, that one looks all right. So let me go fix that empty dialog while I'm here. So if I go over to the event structure, I see, sure enough, whenever you click that do something button, they forgot to wire a string in here. So I should probably put some message in here that's going to pop up in the dialog, right? So maybe do something, button click, go to user state 1. But now I'm actually a little bit worried because what's going to happen when I commit the text to that string constant? I'm starting to worry that whoever wrote this VI, if they're the type of person to have automatic error handling turned on, they're also the type of person to have auto grow turned on their structures. And I'm afraid that this pretty clean diagram is about to get exploded by me typing in that string. But at this point, it's like a train wreck. I can't turn away. I have to see what happens. I'm going to commit that text. Oh no, I was right. This diagram is auto grow turned on the structure. So I need to, you know, that's no good. I'm going to have to do something about that. Maybe move that string constant. So auto error handling was turned on, auto grow is turned on, and I see two other things on this block diagram that I hate as well. The first one is this control terminal right here. It's set to icon view. I hate icon view. Why did the person who wrote this VI have icon view turned on? Now I'm going to have to turn that off. And there's another thing I don't like on this diagram. And I will admit that I might be in the minority on this preference, but I'm going to say it anyway. Let's say you're reading a book and you read a line in the book and you want to read the next line in the book. What do? You move to the left side of the page to read the next line. You don't move to the middle of the page to read the next line. But look at this subdiagram label here. It's set to center justification. So when I read the first line and I go to the second line to read it, I have to go to the middle. That doesn't make any sense to me anyway. I want my subdiagram label justification to be on the left, not in the center. So I'm giving this VI, I made these changes, but now I've seen all these things that I hate about this VI. I need to write a LabVIEW feature so that I can fix any VI that somebody gives me and make myself happy to actually work on that VI. So I'm going to write a quick drop plugin called Make Darren Happy. That's going to be a new feature that I'm going to add to LabVIEW right now. So let me go create a new quick drop plugin. I'm going to save it and call it Make Darren Happy. I'm going to add documentation to it because that's what you should do. I'm going to say this plugin turns off features in LabVIEW that Darren hates. And I'm going to make its shortcut be, how about the letter H, because it can stand for happy or hate, depending on what my attitude is whenever I'm working on the VI. All right, so I go to the block diagram. Oh my gosh, there's so many comments here. If you've never written a quick drop plugin before, you should probably read all those. I have written a quick drop plugin before, so I'm just going to make them all go away. And I'm going to start writing the scripting code to implement this new LabVIEW feature that I'm adding called Make Darren Happy. So the first thing I'm going to do is I'm going to turn off auto error handling VI on whatever VI is being run on with this plugin. So auto error handling is now turned off. By the way, as I'm writing this code, feel free to jump in and ask any questions. All right, so the next thing, yeah, what's up, Norm?
So figuring out what to do for the scripting to put in here isn't always clear. Did you mention, or do you think it's worthwhile to mention the springboard?
Norm, the springboard will be making an appearance later in the presentation.
All right, good enough.
So thanks to Norm for ruining surprises.
Sorry. Well, also the springboard aside, even navigating the VI server, did you kind of hit? I just joined, so I apologize. Did you hit that one at all?
I did talk a little bit about navigating the VI server hierarchy, yes, and I'll have a little bit more to say about that too.
Really? Well, leave you be.
Thanks for checking in on me. All right, so this code I just wrote while Norm was badgering me turns off icon view on all the control terminals on your block diagram. So next up, so I've turned off auto error handling, that's good. I've turned off icon view, that's good. Next thing I'll do is I'll turn off auto grow on the structures. So now I'm going to look for all the structures on the block diagram, and I'm going to turn off auto grow. All right, that's good. Let me make sure to wire my VI reference here. And finally, I want to change the subdiagram label justification on all the subdiagrams in my code. So to do that, I'm going to look for all the diagrams in the code. And I'm going to change their subdiagram label justification to the left justify. By the way, sorry for the kind of sloppy diagram code here. What happens when you throw together a demo real quick? Yeah.
Sorry if I missed you saying this earlier. What's that VI you're using to find the different references inside the structures references, the diagram references, all that? What's that VI?
This is a VI that I will be describing a little bit more later in the slides, but it's called Traverse for G-Objects. So
okay.
You can grab it in QuickDrop like that, or if you use the palettes, which you should not do if you've seen my other presentations, you can find Traverse for G-Objects in the scripting subpalette as well.
Okay, thanks.
All right, so at this point, I have turned off auto grow, I have turned off icon view, I have turned off auto error handling, and I've set all subdiagram labels to justify left. Now, one of the things about scripting, and Norm can attest to this as well, is that there are a jillion corner cases and caveats you have to worry about in scripting. And this whole subdiagram label thing is one of them, because not all diagrams have subdiagram labels. And if you try to do this on a diagram that doesn't have a subdiagram, like this top level diagram, for example, this property is going to return an error. So I would normally propagate errors more elegantly than this, but for now, I'm just going to ignore the errors that come out of that node. So I think my plugin is done. Let's see what VI references are wired everywhere. This all looks legit. I'm going to save this. And now in my VI, I'm going to press Control-Space-Control-H. And you can see that Make Darren Happy has made me happy. It changed the subdiagram justification. It changed the icon view. It turned off auto error handling right there. And if I type in this string, we no longer have a diagram explosion. So in a matter of minutes, I just wrote a LabVIEW feature that is going to make my life more productive in LabVIEW, because now I'm going to have to spend less time changing those settings on VIs that I personally hate to see when I'm working in LabVIEW. Are there any questions about just kind of, I'm going to go into a lot more details about some of the specific stuff I did in this demo, but are there any questions just about how that general flow of being able to implement a feature like that, and how scripting kind of is basically VI server just with more stuff?
I had a question, and if this is something that we talk about later or I missed, let me know. Sure. How do you get this to apply to LabVIEW? So I saw you wrote a VI. Do you need to save it somewhere specific? Do you need to, how would you give it to someone else if they wanted to use it on their computer? Do you know what I mean by that?
I do know what you mean by that. So for this particular plugin, what I ended up doing is I saved it in LabVIEW Data QuickDrop plugins. That makes that plugin available across all LabVIEWs on my system. Depending on what LabVIEW I use to save that plugin in. So I saved this VI in LabVIEW 2020. If I wanted this available in earlier LabVIEW versions, I would have had to have saved it in an earlier version. But later in the slides, when I talk about the specifics of these hooks, I'm going to include links. And every one of these features is going to have a link that tells you how to implement the hook, and things like where to save it, and communities on ni.com to share them. All of that stuff is covered in links that I have later in the presentation.
Okay, thanks.
Sure. All right. So Make Darren Happy. That was a feature that I wrote for LabVIEW in a couple minutes. Well, there's an official version of that feature, and it's called Natify. So if you Google Natify, you will find the download for the official version of this feature, which does way more stuff than the couple of things that I just did in that demo. It's all listed on the slide here. I'm not going to go into all those details, but I posted this tool on ni.com, and people were so excited about it that they started writing tooling around the Natify tool to be able to point at a project and say, I want to Natify every single VI in this entire project. And all of that tooling is also available at the page where the Natify plugin is posted. So, best practices for scripting. First of all, if you are generating code, so in my example earlier, I was kind of tweaking diagrams. I wasn't really making new objects. I was changing the settings on existing objects. But if you are using scripting to create new diagram content, you are going to want to create as few new objects and especially as few new wires as possible, because the scripting code to generate objects, it's a lot of work, basically. If you write a VI to script the random number strip chart, that block diagram ends up being really huge because there's technically a lot of scripting you have to do to create a random number strip chart. So if you are generating code, try to script as few new objects and wires as possible. Use a template that already has a lot of the code that you need. One of the coolest tricks in scripting is if you have a block diagram where there's multiple different things that you may want to script, create a template with a case structure, and the case structure has all of those things that you might want to script. And when it's time to script, pick the right case and remove the case structure. And that'll just leave that code that was in that one frame. That's one of the tricks I use whenever I'm generating code from a template. Also, if you can, use labels on things on the block diagram or the front panel to identify them for your scripting tools. Again, this is where the tref find object by label VI comes in real handy because it's the easiest way to identify objects by their label. And similarly, if you've got generated code that users are going to be looking at, you're going to want to have documentation in there that says, hey, this is generated code. Don't mess with these labels. We might need these labels later. Another tip, do not use the OpenVI object reference function. This function is garbage. People think that they can use this function to find any node on a block diagram by its name. And that's not true because this function does not recurse into nested objects. So if you have an add function called add, and it's sitting inside of a case structure, and you tell OpenVI object reference, hey, give me a reference to the object called add, it's not going to find it because the add is sitting inside of a case structure. What you want to use instead, again, is tref find object by label, that hidden gem that actually does work for finding things by their label. Similarly, if you have a reference to a diagram and you read the all objects property on that diagram, it's only going to give you the top level objects. It's not going to recurse into things. And that's when you want to use the traverse for gobjects VI to find those nested objects. A few more best practices for scripting. You don't need to call the close reference function on anything that inherits from gobject. It's literally just wasting space on your block diagram. LabVIEW does not close gobject references, even if you wire them to the close reference function. I talk about this in my Brainless LabVIEW presentation. I just want to bring it up again here. Unfortunately, the scripting examples have close reference all over the place. Ignore those when you see them because they're not necessary. Now, when I worked in LabVIEW R&D, I was the scripting guy, and so I got all the scripting questions. And one of the things that came up quite often was performance concerns. People had written tools to do scripting, and they were concerned because these tools were very slow. And a lot of times the assumption is that scripting is slow. And the vast majority of the time, scripting is actually extremely fast. The thing that is slow is usually opening a reference to the VI that you want to script into. So we would benchmark an application and find a scripting application and find out that 90% of the time was spent on the OpenVI reference at the very beginning of the block diagram to open the reference. And then all the scripting code after that was really fast. So if you've got a scripting app, if you think it's, if you find that it's slow, it's probably slow just because of the opening of the references. The scripting itself is very often not the bottleneck in those scripting applications. Another thing to worry about is cross-context issues. So in case you don't know, when I use the term context, I'm referring to an application instance. So when you're working with a project, my computer is an application instance, and RT target is another application instance. Most of the LabVIEW hooks that I'm describing in this presentation are running in a private application instance that's part of LabVIEW that customers don't have access to. And one of the things that can happen is you get a reference to an object that's in one application instance, and you try to mess with that object in a different application instance. And those cross-context issues can arise when that happens. So try to operate on objects in the application instance that they actually reside in. And finally, a shout out to our recently crowned Chief TSE, Norm. He's got a tool called the Scripting Springboard that you can download from ni.com. It's one of the easiest ways to get started to experiment and learn idiosyncrasies of scripting by basically giving you a framework to play around with. You don't have to start from a blank VI to start messing with scripting. You can start from the Scripting Springboard. That's why we call it a springboard. And the Scripting Springboard actually includes some scripting functionality for free. It actually includes features like Smashy Smashy. Smashy Smashy is a really nifty editor tool. I'm not going to tell you what it does. You need to go download the scripting springboard and find out. But it's a great learning tool that if you're like, where do I start? Why not start with the scripting springboard? Norm, is there anything you'd like to add to that? You need to unmute your mic if there is something you want to add to that.
There we go. Just one thing. One of the reasons that I made this one is it's very, it's annoying to try to get to an object on a block diagram, even by name sometimes, to try to figure out all the ins and outs. What the scripting springboard does for you is it gives you, it like serves you in a frame. Here's everything that is selected on the last front panel or block diagram that was currently active. So it just monitors LabVIEW, it knows what every time a panel opens up, front panel or block. And so when you hit the button on it, it's like, here's your references, run whatever scripting code you want, which makes it easier because at the end of the day, it's not too different than the keyboard shortcuts, but you don't have to necessarily integrate it into any one location. It's easier to fast prototype out of it because it just gives you those references. And yeah, so that's that.
Thank you, Norm. All right, any other questions on scripting best practices before I move on? Also, Norm, if you could remute your mic, I'd appreciate it.
Got it.
Thank you. All right, so now I'm going to go into details about the actual features with hooks, with scripting hooks in LabVIEW. As promised at the beginning of this presentation, I am going to cover every single possible way you can hook into the LabVIEW editor with scripting. First, I'm going to start with quick drop plugins. So that's what I wrote for my demo. Make Darren Happy was a quick drop plugin. This is what happens when you press Control Space to bring up quick drop. Then you press a Control key combination after that. For example, if you select a function on the block diagram and press Control Space, Control D, all controls and indicators will be created on unwired terminals of that function. That's what that plugin does. There's a whole bunch more plugins as well. And these features, quick drop plugins, are useful for frequent repetitive actions that you do in a VI multiple times a day. And we've got documentation for writing your own. And I was asked previously, like, where do you put the plugins? All the information about how to make your own, where to put them, how to share them is at that link shared in the slide here. There are 10 quick drop plugins that ship with LabVIEW 2020. And there's over 50 additional community plugins available for download at ni.com/quickdrop, which is the quick drop enthusiast group. Now, one of the things that I wanted to do in this presentation was show an example of the scripting code for every feature, every type of hook that I demonstrate in this presentation. So here is the scripting code for wire all terminals. When you press Control Space, Control D, and we create controls and indicators. So you can see here that for every terminal, I check to see if it's unwired. If the terminal is unwired, I then check to see if it is a source or a sink. If it's a sink, I create a control. If it's a source, I create an indicator. Now, another thing I wanted to do with this presentation was every time I showed scripting code, I wanted to kind of show one of those caveat corner case weird things about scripting. And that's going to be the case with every scripting diagram I show from here on out, including this one. What the heck is a hidden terminal? I mean, we've got terminals on objects on a block diagram. What is a hidden terminal? Well, if you've ever used a timed loop, you know that it looks like what I'm showing in the bottom left of this slide. Timed loops have ears hanging off the outside that make them look like Mickey Mouse. They've also got inner ears as well. Well, it turns out that under the hood, the way that the ear of the timed loop is connected to the actual border of the loop itself is with something called a hidden terminal. You don't see any terminals on that block diagram, but they're there, but they're hidden. When I wrote this quick drop plugin, I figured I don't want to mess with hidden terminals when I'm trying to decide if I want to create controls or indicators. So if something is a hidden terminal, I'm just going to skip it. That's an example of the kind of weird thing that you sometimes have to look out for when you're writing scripting code. All right, so another way to plug into the LabVIEW editor is with RightClick Plugins. This is a way to write G-based or G-code that creates right-click menus in the editor. For example, if you look at the picture here, when you right-click on a list box and you do delete all rows, that menu option, delete all rows, that is a right-click plugin. That was implemented with G-code. Right-click plugins are useful for context-sensitive editor actions. So it wouldn't really make sense to make this a quick drop plugin, because why would you want a control key combo to apply to only list boxes when you can pick anything on your front panel? That would be kind of a waste of a keyboard shortcut to have, I don't know, Control L be delete all rows from a list box when the list box is the only thing that it's going to affect. So that makes more sense to be a right-click menu option, because you're actually right-clicking on the object that you care about. And we can provide different items in the menu depending on what you right-click. Again, you can write your own plugins. I actually gave a presentation about this to TSC already, writing right-click plugins. In LabVIEW 2020, we shipped 31 right-click plugins. Just to give you sort of a historical perspective, this feature was added in LabVIEW 2015, and we shipped 6 plugins with LabVIEW 2015. So over the past 5 years, LabVIEW R&D has really adopted this framework as one of the most productive ways to add features to the LabVIEW editor. The RightClick community has over 80 plugins to download, and that's at ni.com/lvmenus. The presentation I gave to TSC is also available at that link as well. So here's an example of a right-click plugin code for create scalar constant, just to give you an idea of what this right-click plugin does. If I bring LabVIEW back up real quick. So if I have an array constant on my block diagram, I can right-click on that and do change to element. And when I do that, it turns the array constant into a scalar constant of that type. So that is the plugin that we're looking at the code for right here. The top picture is the code that runs whenever you right-click. So if you right-click something on the block diagram, that code runs, and it basically checks, is this thing an array? And if it an array constant? And if it is, add the create scalar constant menu item. And then the code on the bottom is the actual scripting code. We take the terminal, we get the data type of the element of the array, and then we create a constant from that data type. Now, what in the world is that function right there? That is called the request deallocation function. What the heck is that, and why do I need that? Well, this is another one of those weird things about scripting. If you ever read the data type property in scripting, or anything that is basically returning a variant that represents a type, LabVIEW does not like accessing the data type of a LabVIEW class across multiple application instances. So in this case, you've got your VI. It might have a LabVIEW class on its block diagram. Then you've got this scripting code here that is also accessing that data type in another application instance. In this case, it's the private application instance that all these right-click plugins run in. When you access class data across multiple application instances, there's a darn good chance that LabVIEW is going to crash. And the way that you can avoid that is by dropping request deallocation in your scripting code. So, Norm, is this a new thing for you?
I was putting LabVIEW Speak on 2020 today, and I've had a couple crashes, and I'm like, that's probably it.
That's probably it. So again, one of those weird corner case caveat gotchas in scripting that you have to know about. All right, so pull down menu plugins. This is probably the easiest way to add a feature to LabVIEW. I'm talking about the menus in the LabVIEW editor, the tools menu, the help menu, the file menu. You can write VIs that will provide new entries in those menus. In fact, all 7 of the ones I have in the red box on the slide, those are all implemented as VIs. And to get those things to show up in the menu, all you do is drop a VI into a certain folder in LabVIEW, and now you've got a menu item. It's one of the easiest ways to add a feature to LabVIEW. We've got a page on ni.com that tells you specifically how to do this, where to drop that VI. And these pull-down menu plugins are useful for a couple of different things. One is if you have an editor action that's kind of based on the environment. The most popular kind of that would be to just launch a tool of some kind. So it doesn't really apply to objects on the front panel. It doesn't even apply to the VI itself. It's just, I want to launch a tool, like find VIs on disk, the first one in the red box there. That's just a tool for the LabVIEW environment that's very easy to launch from the tools menu. Another thing that you might want to put in there is things that you want, editor actions you want to perform on the current document itself. So if you want to do something with the current VI, you can add something to the tools menu that will operate on the current VI. And this is an example of that. So this is a plugin that somebody wrote, I think it might have been me, that lets you explore on just Windows Explorer. It'll show you where this current VI exists on disk. And so you would go to Tools menu and you would select Explore. And this is the scripting code for that. Now, what is that VI that's at the very beginning of that block diagram? This is the VI. It's called Menu Launch VI Information. You pretty much want to use this VI anytime you're writing a pull-down menu option that operates on the current VI, because it gives you the application instance of the current VI and the name of the current VI. So you can then open a reference to that VI and learn information, which I'm doing here, opening a reference to the VI and getting its path. Now, when I open the VI reference, why do I have a 2 wired to the open VI reference? This is a little bit obscure, but if you call open VI reference and you give it a template VI, it's actually not going to open a reference to the template VI. It's going to create a new instance of the template VI that's a whole new separate VI. That's usually not what you want on tools like this. So if you wire a 2 to open VI reference, it's not going to do that. It's just going to open a reference to the actual template VI itself. And then finally, there's an FP close at the end. Why is that? Well, unfortunately, any of these plugins that you write that go into the tools menu, they always show their front panel when they launch. And so you want to make sure to close the panel of the VI when it's done, so that you don't have this VI panel from your tool just randomly sitting there after you've run it. All right, my next hook into the editor is VI Analyzer Test. I already gave a presentation to TSC on VI Analyzer. The VI Analyzer is very useful for performing bulk operations on VIs. So we've talked about, operating on a specific object in a VI. We've talked about operating on a VI as a whole, but we can also have VI Analyzer tests that perform operations across an entire group of VIs. Again, there are utilities and tools for writing your own VI Analyzer tests. The VI Analyzer toolkit ships with 104 tests. And there's several dozen more available on the VI Analyzer community to download. And the VI Analyzer community, which again, I presented on this to TSC before, is at ni.com/VI Analyzer. And at that link, there's also a link to the presentation that I gave to TSC as well. So here is an example of a VI Analyzer test. This may look familiar to you if you saw my presentation on the VI Analyzer to TSC. This is a VI Analyzer test that not only detects when I am using terminal view on icons, but it will also correct it. It will turn icon view off on terminals and then save the VI. Now, it can be a dangerous thing to have a bulk processing tool like the VI Analyzer actually make edits to code. So if you do write a VI Analyzer test that does modify code, you need to be very careful when you call save instrument. One of the most common snafus that I've seen is when someone has a code base that's saved in, let's say, LabVIEW 2018, and then they open up LabVIEW 2020 and run a VI Analyzer test that modifies code. Let's say they ran this very test that you see on my screen right now to turn off icon view on terminals. Well, when the test calls that save instrument, it saves the VIs in the version of LabVIEW that's running this test, which in my example I just gave is LabVIEW 2020. So now you have just converted your whole code base to be saved in 2020. You may not want that. You may have clients that are still using LabVIEW 2018, and now you've gone and resaved over all of the code in LabVIEW 2020. So all that to say, you've got to back up your code. You've got to use source control, especially whenever you are using bulk processing tools like this, that if they're modifying the VIs, may very well modify them in a way that you didn't intend. So definitely an advertisement for source control here. So to summarize those 4 main hooks into the LabVIEW editor, quick drop plugins are useful for repetitive actions performed dozens of times per day on a particular selection of objects on the front panel or block diagram. Right-click plugins are for context-sensitive operations. You've got something that you want to do just to list boxes, add that to the list box right-click menu. Don't make a quick drop plugin out of that. Now, there is one exception to that. If you've got something that's repetitive, but you can't restricted to a selection boundary, then you might need to use a RightClick plugin. And the example for that is given in the slide here. You cannot select a terminal on a function. Like if I've got an add function on my block diagram and I want to select just the bottom input terminal, I can't do that. When I click on add, it selects the whole node. RightClick plugins do go down to that granular terminal level. So if there's a repetitive action you want to do, but it's on a like lower than the selection boundary, if it's on a terminal boundary, for example, then making a RightClick plugin for that repetitive action makes more sense. I hope that was clear. Then you've got pull-down menus. These are great for environment-based actions or actions on the particular document that you're looking at right now. And then there's VI Analyzer, which is performing bulk actions on multiple files, like all the files in your project, whether that's for code inspection or code modification. All right, so here are several miscellaneous additional hooks into the editor. Did you know that you can write your own icon editor? You can completely replace the icon editor that ships with LabVIEW, and a lot of people have. Information on that is provided in the link in the slide. You can also provide your own code for when someone does edit, create sub-VI. That feature is completely implemented in G. That's all scripting code that's creating a sub-VI when you do edit, create sub-VI. If you like what that feature does and you don't want to replace that scripting functionality, but you want to add something like sort of a prologue or an epilogue to the scripting, the Create Sub-VI plugin allows you to do that as well. You can basically say, yeah, go ahead and do all the scripting you would normally do, and then I've got this extra thing I want you to do at the end. If you don't use the bookmark manager, you absolutely should. It's a great tool. My favorite use for it is code reviews. I love to have somebody basically bookmark the parts of the code that they change, and then when it's time for the code review, they bring up the bookmark manager and we just go through the items one by one that way. It's one of the easiest ways to do a code review, but you can write your own bookmark manager. Somebody wrote their own and posted it to ni.com, where in addition to showing all the bookmarks like it normally does, it also shows a preview of the block diagram area around where the bookmark is, which is a pretty nifty little feature. You can add your own entries into the Create Project window. A lot of NI Alliance partners do this. They've got in-house project templates that they use for developing their own applications. They've made entries for the Create Project dialog where their stuff shows up in there to be able to create a new project from there instead of having to do a file save as or to create a project from scratch. And then I'm going to guess that most of you have not done much with channel wires. But believe it or not, you can create your own channel wire types. And that is documented on ni.com about how to do that. All right, so another thing you can customize is the content that you see in the File New dialog. The first thing you can do is you can add a folder just for your templates and then a text file that describes your templates. Then for every one of your VI templates, you can add an image file next to it. If you look in the screenshot in the bottom left, you'll see for every one of my templates, I also have a PNG file with the name of the VI and then a D at the end. The D stands for diagram. Once you've done that, every one of your templates will show up in the new dialog with a name and a screenshot and a description. So it's a really easy way to have your own stuff show up in the File New dialog. Then, if you work with LabVIEW classes, there are lots of ways to customize all the different things that you can do when you create new class VIs. Like if you right-click on a class in your project, you have the option to make new VI for override, new VI for data member access, new VI from static dispatch template, new VI from dynamic dispatch template. There's a lot of different ways to make new VIs for classes is what I'm saying. And you can customize those things. For example, after the VI is created, if you want to write your own scripting code that makes some sort of modification to the VI, you can do that. You can change what the templates look like. If you don't like the fact that there's an error case structure around the contents of every new accessor you create, you can get rid of that in the template. So when you make a new class VI, it's not in the new VI anymore. One thing that I've noticed people do is they don't like the naming of new accessor VIs. They don't like how they're called readdata.vi and writedata.vi. They would rather than be called getData and setData. you can change those strings as well. Basically, just go dig around in that LV class library folder and see what you can find and see what you can change for the things that you can customize for making new class VIs. Now, I want to talk about custom probes for just a minute. Again, this is a point of the presentation where if we were in person, or if more of you were sharing your video, I would ask how many of you have created custom probes before. But custom probes are extremely easy to create for visualizing certain data types on your block diagram when you probe them. There's a help topic telling you how to do it, and there's already lots of great custom probes available. Back in LabVIEW 7.0, which a lot of you guys were probably still in diapers back then, I wrote a set of probes called history probes, and those got downloaded from NI.com thousands of times. And I finally got the time and resources to add them as a feature to LabVIEW in LabVIEW 2019. So now, if you right-click on any regular data type, you'll see a history probe that you can make, and that will give you a history of all the values that have flowed through a wire. It's an invaluable tool for debugging, particularly if you're working with queued message handlers, string-based state machines, and even if you're working with an enum-based state machine, you can make a custom probe based off of one of my history probes with your specific enum in it to be able to have a very quick history probe for your specific enum. There's statistics probes available on NI.com. You can make a probe for your own LabVIEW class wire so that when somebody probes it, they will see your probe of the data you've decided to share from that class. And then next up is a feature that probably none of you have ever heard of, which is data agnostic smart probes. That is a feature that was added in LabVIEW 2016, and not very many people know about it because I think people are still trying to figure out what exactly to use this feature for. This is a way to make a probe that is not tied to a specific data type. So prior to data agnostic smart probes, your probe had to exactly match the data type of the wire that it was probing in order for it to show up in the list. Not the case with data agnostic smart probes. You can make one of those things that can probe any wire in LabVIEW. But the thing is that you don't gain access to the data on that wire since it knows nothing about the data type. So in LabVIEW R&D, we were trying to figure out what can people use these things for. Well, one thing that people can use them for is timing information, which is shown in the screenshot on the slide. You can see the 1, 2, 3, 4 probes in the bottom picture are all on different data types. And you can see in the probe watch window, what we have is the ability to see how much time has passed between executing one of those probes and the next probe. So it's a really cheap way to get a timing benchmark on a block diagram. Another reason, another thing we found to use for in data agnostic smart probes is changing VI properties. So in LabVIEW 2019, we added a feature that's been asked for years to be able to toggle execution highlighting on a block diagram. So if you put one of these probes in one spot on your diagram and you put another later on your diagram, then when you run the VI, highlight execution only shows up in that section of the diagram between those two probes. Norm, had you not heard of that feature? It's in 2019 and later. Now you get to play with it. Anyway, data agnostic smart probes, I think, have a lot of other uses as well. These are a couple that we thought of in R&D. I'm hoping other people can think of some as well. Norm, did you have a question?
I did have just a quick note about custom probes, not necessarily the data agnostic ones. You know, since you're drinking, I'll give you a chance to breathe. Darren's made it, you know, a lot of people, even customers, in terms of trying to help them engineer ambitiously, even just taking the standpoint of don't be afraid to let something like a custom probe or even a quick drop shortcut be something ethereal. Don't, because there's a mental block a lot of people hit, especially for custom probes, where it's like, oh, I have to invest in really making something that's good. No, if you just want it for 5 seconds, just put the delete me as the name, do the thing, make your life easier. Darren probably already mentioned that earlier on, and then move on with your merry life and let the probe exist, delete it later. More often than not, when I've done that, I actually find like, oh crap, that probe still exists. Perfect. Even though it's kind of hokey, maybe it doesn't work the best, but that having that lower barrier to entry mentally helps me do that. And then also advocating for our customers as you're trying to help them debug their own problems. And they're like, and you want to see some information from them specifically, and they're like, oh, let me export it to an Excel file or something. I'm like, no. Here, let's make this thing together. or whatever. Is like, here's a little probe for you. Just drop it on the wire, and it's gonna do what it need to do. Like run a VI and then have a probe. And every time that the probe runs, it sends the information over to your VI that you made to do extra logging of stuff. So the probe doesn't even need to do anything except shove information into a queue or something like that. So thinking dynamically with some of these tools that Darren's talking about can really help us help our customers debug their problems, because they're not thinking like this. So you get to teach them, and also you can help make the debug process real fast, and you'll blow their minds.
That is an excellent point, Norm. My custom probe folder on my computer is full of random probes that I threw together because I needed something real quick. And most of the features in this presentation, you can put together really fast. I mean, you saw how fast I put together that quick drop plugin. A custom probe takes seconds to create. We've got a wizard. When you right click on a wire and pick probe new, you get a wizard that lets you create a new custom probe based on an existing one, and you can make one in seconds that you can then tweak the way you need it. So excellent point, Norm. Thanks for sharing that. All right, and with that, we will get into rusty nails. So this term was originally coined by Greg McCaskill, a longtime LabVIEW R&D member, and he equated these types of features to going to your grandma's house and finding out that she's got an attic with all sorts of really cool, neat things in that attic that are hidden, like, maybe old toys or maybe old photo albums. I don't know, just really fun stuff that she has up in her attic. So you go sneak up into grandma's attic and you find all this really cool stuff. But while you're up there, you also notice that the floor of the attic is just full of rusty nails that you could step on and get an infection in your foot. So basically, all of these features I'm about to describe, they are technically part of LabVIEW and ways that you can hook into the editor. And I told you that I would tell you about every way to hook into the editor. But all of these rusty nails, you should never, ever use. You have been warned. First one, callback VIs. So if you go into your LabVIEW right now and look in the LabVIEW resource folder, you will see, oh, look, Norm's got his scripting shirt that has a rusty nail shoved into his heart. So Norm knows exactly what I'm talking about. So callback VIs, in the resource folder, you will find several of these right now if you go look in your LabVIEW, and they can define new behavior for various editor actions. If you press Control-N to make a new VI, you can have a callback VI that does something else when you press Control-N. When you press Control-Q to exit LabVIEW, you can have a callback VI that runs a VI to do some weird thing when you quit LabVIEW. But don't ever use the callback VIs because they are an extremely old, brittle technology that existed before projects. So these things existed when I was in middle school. That tells you how old they are, okay? Well, whenever projects were added to LabVIEW, nobody bothered to go make the callbacks aware of application instances. So now, if you try to make your own really cool, slick Control-N callback VI, but you've got a project window open and you press Control-N and you expect your callback to know anything about that project, you are going to be sorely disappointed. So don't write callback VIs. Next up, project providers. So a lot of the functionality that is in the project window is provided by G-based project providers, VIs that people have written. Everything that has a red box in this screenshot is actually provided by, added to LabVIEW with G code in project providers. You will often see, okay, I won't say often, you will occasionally see people give presentations on how to write project providers. Don't ever go to them and don't ever listen to those people because project providers are the worst. I had to maintain several provider-based features when I was in LabVIEW R&D, and there are a jillion corner cases and stability issues with them. And we have to debug those in LabVIEW R&D every time something broke. One time, there was one that I had to fix where I had to go in and manually right-click on every OpenVI reference that was in some scripting code in a provider and set a hidden flag on those guys that nobody outside of NI even knows about. So if somebody wrote a provider and had the same problem I had that I was fixing, they would have no way to fix it because of that weird hidden flag. Don't write providers. If you see somebody talking about writing a provider, slap them or do something to convince them otherwise. Note that in TXE, you do not have to support customers who try to write project providers. You can kick them in the butt if you want to, for all I care. That's what they need to get whenever they decide they want a project provider. All right, XNodes is the next one. An XNode is a way to create a new diagram object. Believe it or not, the three objects you see on my screen here are XNodes. Match regular expression is an XNode. It is not a built-in primitive in the language. XNodes are written with G code, as I mentioned before, and the reason people write them is because they can do things that you can't do with a regular sub-VI. You can make growable XNodes. You can make XNodes that when you click on them, pop up a dialog. Those are the things you can't do with sub-VIs. Unfortunately, XNodes also have all these corner cases and no documentation. A lot of their functionality is hidden behind licensing. So customers end up having to hack around our licensing to be able to write XNodes. It's just bad news all around. Now, all of the rusty nails I've described so far are not official features. They are not supported by NI. Sadly, my next rusty nail is supported by NI, and that's X-Controls. X-Controls are an official feature of LabVIEW. They allow you to create new front panel objects and define custom edit time behavior of those controls and indicators. They allow you to define new properties and methods in VI Server, but I have seen enough corner cases with X-Controls being used in large projects that involve classes and pet project libraries that I cannot in good conscience suggest people use them, because I'll see these customers with these big applications with these really rich, elegant X-Controls that they've implemented, and they all of a sudden start getting compiler errors and dewarns and other issues that they end up having to call NI support about. And ultimately, the problem ends up being something with the X-Control framework. Now, NI fixes those issues when we find them. Those issues get reported to R&D as bugs. R&D fixes them. But I can't trust the feature enough to use it in the future, knowing that one of these bugs is inevitably going to happen. So that is my own personal opinion, but I don't use X-Controls, and I suggest people don't use them either. Now, there is an alternative to X-Controls called Q-Controls, which provide almost all the same functionality as X-Controls, but they're not built on top of X-Control technology. One of the things about them is that they are portable to LabVIEW and XG. X-Controls specifically will never port to NXG. LabVIEW R&D has said X-Controls will not port to NXG ever in the history of the planet. But Q-Controls don't use X-Control technology, so they can port. So if you find yourself wanting to design a custom control for the front panel, I suggest starting with a Q-Control instead of an X-Control. That's all I have. I'm exactly at 4 o'clock. If anybody has like a really super quick last minute question, feel free to ask me. Otherwise, thanks for attending, and you can download all this material at bit.ly/dnatlvhook. So